Okay, so today we're going to continue with chapter 3. And let's just remember chapter 3 is numerically summarizing, I had to think of what it was, data. Okay. In last class, we were talking about data position and we looked at that doesn't want to focus, so we'll give it a minute. We looked at the empirical rule, the z-score, and then we took a look at percentiles, and we just started talking about percentiles. Now we're going to kind of go right off that percentile, so we're going to keep working with data position. And from percentiles, we're going to start talking about quartiles. Quartiles are a type of percentile. See if that will focus now. Okay, that's a little better. Okay, so quartiles are a type of percentiles, and what the quartiles do is it's going to give me these points that divide the ordered data set. So I'm going to put ascending right here because I want you to know it's from smallest to largest into 4 parts. So into quarters, okay? So what we're looking at here, just to give us a visual, if this is my minimum value on the left and on the right is my max, then right here in the middle is my median. My median is also called quartile 2. It's the same thing. Then here on the left between my min and my median will be quartile 1, and between the median and the max will be quartile 3. Now, when we're looking at these quartiles, this breaks my data into quarters. So it's 25% here, 25 here, here, and here. So let's talk about what these quartiles are, and then we're going to look at how to calculate them. So quartile 1, this says that 25% of the data is less than quartile 1. Quartile 1 is the median of the lower half of the data. So I'm looking at the median, right, is the middle point. So if I'm looking at the lower half, that's everything over here on the left, quartile 1 is the median for that lower half. And this can be called the 25th percentile. Now let's look at quartile 2, which we already know a lot about quartile 2 because it is the median, and we've talked about the median last week. So quartile 2, when I have 50% of the data is less than quartile 2. So it is to the left. Quartile 2 is equal to the median. So it is the median. Oops. Sorry about that. Median there. And this can be called the 50th percentile. Okay. Then lastly, we have quartile 3. And this is where I have 75% of the data is less than this quartile. This is the median of the upper half of the data. And here we can call this the 75th percentile. So these are special percentiles, and we're going to look at these. So quartiles, I'm gonna write this down. Are far from the smallest and far from the largest data values. So they are resistant to outliers. So let's just take a look at our drawing here. Say my maximum value is an outlier. Maybe it's just really large compared to all the other data values here. We don't have the data values, we're just picturing this. Say this is an outlier. My quartile 3 is this far away, and median and quartile 1, they're far away from these values. And these could be outliers, my min and my max. They could be far from the rest of the other data, but since the quartiles are far from those values because they're inside, and it actually represents that middle 50%, right? Then they're called resistant. So that means an outlier does not affect those values. So when I have an outlier part of my data set, my quartiles are not affected. So we call that resistant to those outliers. And this is good to know because if we have outliers in our data sets, then our quartiles are a really good number to use because, and they're more meaningful because they are resistant. When we're looking at our quartiles, we have what we call interquartile range. And my interquartile range is IQR. Okay. And IQR is equal to quartile 3 minus quartile 1. So again, I'm just gonna show that visual for us here. So the interquartile range is the range between these two numbers. So it gives me the distance. So it gives me the range of that middle 50%, where half of my data is, gives me the range. That gives us some pretty good information. The interquartile range is used when we do not have a symmetric or bell-shaped data or distribution. So if I have something that's skewed, interquartile range is a good one to use. What is the interquartile range? What does it tell us? It tells us the spread. So IQR is a measure of spread. So we use that to tell us the spread of our data, right? How spread out it is. And I'm just going to write a reminder that the median is a measure of center, right? Or our typical value. I'm just going to write in parentheses. We've already talked about that last week, but I like to remind you because when we're studying this stuff here, this data position, we're looking at quartiles, we use that median or quartile 2 for our center. Okay. So let's take a look at an example and we will calculate these 3 quartiles and we're going to keep going with that same example and those quartiles a little bit here today. So the first example we're going to look at, let me get this written out here. So the data represents the amount of money I'm going to put in parentheses in dollars, it's rounded, excuse me. Spent on junk food last Thursday by 20 students in my pre-calc class. Now, I'm not going to give you the raw data. I'm actually going to give you the order data. So I'm going to order in ascending order. So it means more to us. We can actually just use that. So I'm not writing it over and over again. So I have 20 different data values I'm going to write down. Okay, hopefully I have all 20 there. So those are my 20 data values that I collected from the 20 students in my pre-calc class. This is how much they spent in junk food last Thursday. So what I want to do here, I want to find the 3 quartiles. Now, we're only going to do this right now by hand, and then going forward, you will use your technology, so your calculators or Minitab or whatever you are using, okay, for that. So when I do this by hand, I'm actually going to start with quartile 2, and you're going to see why in just a second. So let's go ahead and say quartile 2. Remember, quartile 2 is my median. So we already know how to do this, but we'll work through it again just in case someone missed that or they forgot or they didn't get it the first time. So when I'm trying to calculate the median on my ordered data set, I need to know how many data values I have. And that's going to drive me to which method I use. So n is equal to 20, right? Because I already said I have 20 students. Since 20 is an even number, that's when I'm going to take the 2 middle values and I'm going to average them, right? Because I don't have a single middle value. So I have to take the 2 middle ones and average them. So that's where I'm going to take the value that's in the position of n divided by 2 and n divided by 2 plus 1. Now I'm going to show all my work so everyone can follow along, although we probably could already see what that is. So my n is going to be 20 divided by 2, so that is going to be the 10th position. So the data value in the 10th position, and I have 20 divided by 2 plus 1, so that will be the data value in the 11th position. And I'm going to average them. So 10 right here is the number 5, that data value, and 11 would be number 7. So I'm going to add them and divide by 2 because I'm averaging them. So that gives me 6 is my quartile 2. So I'm going to just box it off so it's easy to find when we need it in a little bit. Any questions on that one, on that part of it? Okay. All right. Remember, you could always ask me after class if you have any questions and you don't want to ask in class. Quartile 1 is the one I'm going to work on next. So remember what I said for my quartiles, what they are, or how I calculate them even. Quartile 1 is the median of the lower half. So since I did quartile 2 first, I can actually cut this data in half, and that's going to be useful for us. So when I cut it in half, I already did the quartile 2. I already know the 2 middle values. I'm just going to draw a line there so I know. So now everything over here on the left side of that red line, that's my lower half, and then everything on the upper side on the right is my upper half. So quartile 1 is going to be the median of this lower half. Well, if you look at the lower half, I have 10 values, right? So for my quartile 1, I'm actually going to look at n is equal to 10 to do it out mathematically here. I know I can look at it and I can tell what it is just looking at it, but let's actually use the formula. So here I'm going to do the same thing I did above because 10 is even. I'm going to take n divided by 2 and n divided by 2 plus 1. So this gives me 10 divided by 2, which is the 5th position. And I'm going to look at 10 divided by 2 plus 1, which is going to be the 6th position. So from there, I'm going to average them. So when I look here, I have 1, 2, 3, 4, 5, and 6. So the 2 numbers in the 5th and 6th positions are both 5. So obviously the average is 5, but I like to write it out so we can see. if we ever look back at this, where we get our number. So that is quartile 1 is 5. I've done all the hard work, and it really wasn't that hard of work. It's just now I've done the work. So quartile 3 is going to fall into place really easily here. And quartile 3 is going to be the median of this. So I could go 2 different ways here. I can say, well, if I just look at my upper half, it's going to be, again, the 5th and 6th data positions and count them out. Or I can say, okay, well, the bottom half was a 5th and 6th. And then I have 10 data values here, right? So I could take that n, that 10, and add it to 5 and add it to 6 to get 15th and 16th, because that's where I'm going to be at up here. So I could go 2 ways, 5th and 6th, or the 10 plus the 5th and 10 plus the 6th to give me 15th and 16th. So I hope that makes sense to everyone. And that's kind of like a little easy way to do that. So 15th and 16th. So when I look at that, it's 10 and 10. So I'm going to average those, which of course is just 10. And that is my quartile 3. And here it is. So there I found all 3 quartiles for this data set by just taking the median over and over again. Okay. So we have a way we can organize these quartiles, and it's called the 5-number summary. So the 5-number summary, what this does is this takes these quartiles and the min and max and puts it in a little summary in a specific order. So if someone says, here's my 5-number summary, then I know a lot of information about their data set because I know how they broke it up into quarters. I can look to see the IQR quickly by subtracting quartile 3 and quartile 1. I can look at the overall range. You could see a lot. So you could see that middle 50%. So the 5-number summary is just going to be my smallest value, so my minimum value, then my quartile 1, then my quartile 2 or my median here. I'm going to write median and then I'll, in parentheses, write quartile 2 because it's the same number. Then quartile 3, and lastly, my max value for my data set. And this is my 5-number summary. So it's the min and the max and all the quartiles in order. It always goes from smallest to largest, right? Min, quartile 1, 2, and 3, max. Okay, so all the numbers should go right in order. Okay, so let's take a look at this with this last example. So we're going to use the above example. So if we take a look at our raw data here, I can see my smallest number is 3 because it's ordered. So I have a 3 here, and we calculated the quartile. So let's take a look. Now remember, they're out of order, right? I did quartile 1, or I'm sorry, 2 first. So quartile 1's in the middle, so that is 5. My median or quartile 2 is 6. And my quartile 3 is 10. I have that there. Then I'm going to look back at my data set, and I see over here my largest data value is 21. And that completes my 5-number summary. So just looking at this, I could see, okay, my general range here, right? It's 18. I can see my IQR. So that means 50% of my data values are between 5 and 10. So it's like pretty clumped right there, between $5 and $10. That's half of the data. That's my 5-number summary. When we have a 5-number summary, there's a way to graph this. So it gives us a nice visual, and this is called a box plot. So a box plot is just the graph of the 5-number summary. And then I want to say plus a little more, okay? Because it's not just those 5 things. I add a little bit more. If you just do a general box plot, it is just those. But I think we get a little bit more information when we actually add a little bit more to the box plot. So even when you're using technology, I'll say add this to it. Gives you a little bit more. Okay. So I'm going to draw a general box plot, and then we'll go back to this example and we'll base it off these numbers here. So when we have a box plot, you first start out the box plot by drawing the 3 vertical lines that represent the quartiles. So this first vertical line represents quartile 1. The next one represents quartile 2, or the median. I always write it like that so then you guys can see it's the same number. And then the last vertical line is quartile 3, okay? And then I box those in. So I'm just going to draw some horizontal lines to box that in. So here's my box of my box plot. Now, when I have my box plot, it represents like these 3 middle numbers of my 5-number summary. And then I'm going to put my min and my max in. But I have to do something else first. So the thing I have to do first is I have to calculate what we call fences. So these fences are the cutoff values for my upper and, or for my outliers, I'm sorry. So I have an upper and lower fences. So let me write this here. So the cutoff values for outliers equal to an upper fence and a lower fence. So let me tell you how to calculate these. So my upper fence, and of course I abbreviate, you'll notice I do that all of the time, just try to save some time. My upper fence is going to be equal to quartile 3 plus 1.5 times my IQR. So all of this information can be gathered from my 5-number summary. Think about my IQR. That's the difference here. It's the width of this box. I'm going to take 1.5 times that. I'm going to add it to that quartile 3, and that's going to give me my upper fence. And then I use the notation of just like a bracket for that. So I'm going to just put it here because this is just general. We're not actually plugging numbers in right now. Then the other one is my lower fence. And I'll call this LF. This is quartile 1 minus 1.5 times IQR. So I'm going to take that same value. I'm adding it to quartile 3 for my upper fence. I'm subtracting it from quartile 1 for my lower fence. And then I would put that somewhere over here, wherever it is. You don't need to place values on any of these. You don't need to label these because you'll see when we do an example, we will do like a scale at the bottom and it will line up and it will match up. Some people like to label them with numbers or what they are, and that is fine as well. Do whatever you're comfortable with, but I want you to know you don't need to do that for me. So these fences are cutoff values for outliers. So what that means is if I have a number in my data set that is outside of the upper fence, so meaning over here to the right, or outside of the lower fence, meaning over here to the left, then that means those are outliers. So I'm going to mark those with a different notation with a little star. I'm going to put 2 on here because I might have more than 1. And I'll just make a little note that these are outliers. All right. So my outliers are just noted with these little stars. They're data values. It's just they're far from the rest of my data. Now we have to include the next part of the graph. So it's not just the box. We have something what we call whiskers. So the whiskers are the tricky part for most people. Most people can get all of this and they're good. The whiskers just get a little tricky because they're not sure where to stop the whisker. So these whiskers are these horizontal lines that come out the side of my box. And you'll have them almost all the time on both sides. Once in a while, some data is not great and you might be missing a whisker. So how do you know what to do with these? So I'm just gonna write right here that this is a whisker, just to label it. Again, you don't need to label these things for me when you do any of this for me. That's a whisker here. So how do I know where these go? this whisker will go to the largest data value inside the fence. Okay. So this whisker will end at the largest data value inside my upper fence. When I say inside, I mean closer to my box. And the same thing for this whisker, but just the other way around. It's going to end at the smallest data value inside my lower fence. So again, if it's outside my fence, it's to the left here on my lower side, that means it's an outlier, so it's going to be inside. Once in a while, my whisker will go to my fence because maybe my fence is the same as that next largest data value. But most of the time, it doesn't really go to it, and that's the mistake people make. They don't know where to stop the whisker, so they just keep going to the fence. You only want to go to the data value inside that fence. So let's take a look at an example, and hopefully we have an outlier so we can address this and take a look at it. So here, for this example, we're going to use the same example as above. So I'm going to use that same data set, and I'm actually going to write the 5-number summary over here, then we have it. So for my 5-number summary from that previous question, and then we can draw our box plot from this. Okay. All right. So the first thing I'm going to do is I'm going to draw some sort of scale. So I'm just going to draw a horizontal line. It's not even a straight line, and that's okay. It doesn't matter. And I'm going to put a scale on it. I'm going to start with 0 and then count by 5. It's just what I'm choosing. It's not right or wrong. It's just what I'm picking. So you can choose whatever you want, just as long as there's some sort of scale for you to see. Okay? So whoever's reading your graph, they can see what you're doing. So my box plot now, like I mentioned before, the first thing I'm going to do is I'm going to write vertical lines over 5, 6, and 10 to represent my quartile so I can get my box on there. So I do it right above. I don't even do it right on the scale. I do it above the scale. Okay, so 5, and then 6 is there, and then 10. And I box it in. So there's the box of my box plot. Now, the next thing I need to do is I need to calculate my fences because I don't know where my cutoff values are. I don't know if I have outliers, so I don't know where to put those whiskers, basically, is what I'm trying to get at. So for my upper fence, I have quartile 3 plus 1.5 times the IQR. Well, just over to the side, I'm going to write IQR is equal to quartile 3 minus quartile 1. Quartile 3 is 10 and quartile 1 is 5. So my IQR is just 5. So I can plug that in now. So my quartile 3 is 10 plus 1.5 times IQR, which is 5. So this ends up being 10 plus 7.5, which is 17.5. So that is my upper fence. I'm going to mark my upper fence here at 17.5. So that's right around here. It's my upper fence. Now let's take a look at a lower fence. So the lower fence is quartile 1 minus 1.5 times the IQR. We already calculated the IQR over here. It's the same for the data set, the entire problem. It doesn't change. So quartile 1 is 5. So I have 5 minus 1.5 times 5. So I see what's going to happen here. I'm going to have a negative number because I have 5 minus 7.5. So negative 2.5, and that's okay. This is real data. So when we have real data, sometimes things don't look perfect and they don't work out the way we think maybe in our minds. I understand and you understand that negative $2 cannot be spent on junk food. And that's okay. That just means I'm not going to have any values outside of that. I'm not going to have any outliers or unusual values on the lower end. Okay, and that's okay. I just included it on my graph because it's part of it. Sometimes someone might say, well, it's 0, and that's fine because they say that's like what works for the data, and that's all right. I'm not really picky about it in that way. Okay. Any questions so far on that? So now here's the tough part. I need to recognize, and I have to pull up my data for this. I need to recognize if I have any outliers. And if I do, I need to write them down by using like a little asterisk or a star. Then if I do, I need to make sure I look at the correct value to draw my whisker to. So let's take a look at that. So my largest value in my data set is 21. 21 is definitely larger than 17.5. So I am going to mark 21 as an outlier. So right here, I have an outlier. I could have more than one outlier, so I need to keep looking. We already said we wouldn't have any on the bottom side because it's a negative fence. So that's that one we don't have to look at. So now I'm going to look at the next largest value in line, right? So I'm going to work my way from the right to the left. It's 15. 15 is less than 17.5, so it's inside my upper fence. It's closer to my box than my fence, so that is not an outlier. That's actually going to be my maximum number where my whisker will end. So I take this next number in line, 15, and I'm going to just put a little point there, and my horizontal line will go to that point. Okay, so that's where my whisker ends, at that next largest data value inside. Now I'm going to do the same thing on the lower side. I need to draw my whisker. My smallest value is 3. 3 happens to be the actual minimum value of the data. It's not an outlier, so that's where my whisker will end. So right around here. And that is my box plot. It shows my fences, it shows my outliers, my quartiles, the range of my data. I get a really good information from this. I get a lot of information. And I'm going to add one more thing. So I'm going to tell you that I already calculated the mean on all of this data, and I found the mean to be equal to 7.65. I'm going to take that information, I'm going to mark it on my box plot. So this is what I'm saying, I'd go a little bit further and I take a little bit more. So I can only do this if I'm given the mean or if I have the raw data to calculate it myself. But 7.65 is somewhere right around here. Okay, and we mark the mean with a plus sign with a circle around it. That's the indication of mean on a box plot. The reason why I include the mean on a box plot is because now I can look at this and I can compare my mean to my median, and hopefully I could tell the shape of my data set. Right? So remember last week we talked about if I have mean and median and what they mean, their relationship to each other, and what that means for the shape of my data. So that's drawing the box plot from this example. Are there any questions on that example before I keep going? Okay. What shape do you think this is? Do you guys have an idea of what shape this might be, this data set, just based on looking at the box plot? Knowing that the mean is larger than the median. The mean is getting pulled to the right with all those data values, skewed right. Yeah, thank you. So this is a skewed right. So I'm going to write out the shapes. So I have a box plot and shape of a distribution. And I'm going to write them out because I feel like it's nice to get a visual to go along with knowing the relationship between mean and median. So here for symmetric, I might have a box plot that looks something like this. And my mean is probably pretty close to my median. It might not be exactly. This would be symmetric. My whiskers are generally the same length. The box is, the median is pretty much in the middle of the box, that kind of thing. The mean is close to the median, that's symmetric. Now, if I have skewed right, I'm going to be a little dramatic with it because then I feel like it gets the point across a little bit more. So maybe I have something like this. You can see the whisker to the right is a little bit longer. The box is a little bit wider on the right side of the median than it is on the left. The mean is on the right. This is skewed right. And this is what we had in the other example. I would say it looks skewed right to me. Then we have just like the mirror image of this one for skewed left. So I have a longer whisker on the left. The mean gets pulled to the left. I have more area in the box to the left of the median than I do to the right. And then look, this little short whisker. This is what I would call skewed left. Okay. Now, when we're looking at our data sets and we decide to draw some box plots, we might be asked to take 2 or 3 or multiple box plots and compare them. So if we want to do that, there's some certain things that we want to look at for comparing these. And when we look at these, I just have to grab another piece of paper here. When we look at these, we are looking at comparing what we generally look at all the time, which is the center, the spread, the shape, and if we have outliers. So it's really the same thing. So if we want to compare box plots, I want to compare the center or the typical value. Remember, we can use those interchangeably. So typical value, generally when we're looking at typical value or the center for this in the box plot, we're looking at the median. Or it could be quartile 2. That's my line in the middle. We want to compare the spread of the box plots. So we're comparing from one box plot to another. When we're looking at the spread, we want to take a look at the IQR. So we're not going to look at the standard deviation here. We're not going to look at the range. We're going to look at the interquartile range. So we want to look at the width of the box. We look here, the width. We want to compare them. Okay. And then we want to look at the shape and compare the shape. And like we just talked about, when you look at the shape, you're going to compare within each box plot the mean and median, and I'm going to write within each, because you're not comparing the mean from this one to this one and the median from this one to this one. No, I'm going to say, okay, looking at this box plot, the mean is less than the median, so it's skewed left. Okay, now separately, I'm going to look at this one. The mean is greater than the median, so it's skewed right. Okay, so this one has a skewed left box plot, that one's a skewed right. That's all we're talking about. And then, of course, if we have any outliers, you want to make sure you pay attention to those outliers and make a note of those. So some data sets have outliers. You may have multiple outliers, and then others won't have any outliers, and it's okay. It's just the way it works out. So it's just something we want to make a note of. Remember, quartiles are not affected by outliers, but the mean is. So the average is, it gets pulled with those outliers. So it's important for us to pay attention if we have any of those. So that's why we want to just make a note when we compare box plots about outliers. So that's really nothing new. It's just now looking at the box plot to do that. Do I have any questions? Do you guys have any questions for me? No questions?